Good day, viewers. Whatever time you may be in your location, I am greeting from Cameroon's time. In today's video, we are going to see some important features to use while solving quadratic equations. I am Tem Achemkezengum presenting this script. So follow me as I go. Basically, we saw that quadratic equations are generally represented by ax squared plus bx plus c equals to 0, where we said that a is different from 0 and a, b, c are elements in the set of real numbers. Basically, this is a polynomial whose degree is 2. So that is a general form of a quadratic equation. Now, when we manipulate this equation, let's say we want to isolate this coefficient here to be 1. We divide all through the equation by a. Basically, we had x squared plus b over a x plus c over a equals to 0. Now, if we write this as x squared minus, because I can write this one as negative times negative b over a times x plus c over a. This is basically the same thing as b over a, because this time this will give positive, negative times negative. Now, having this in mind, right, this quantity here is called the sum of roots. So any quadratic equation basically can be written as this one here, right, is called the sum of roots. So the sum of roots, I can denote it by s, is given by negative b over a. And the product of roots p can be written as c over a. So following this property, it means that any quadratic equation can be written in the form x squared minus, this is sum of root s, plus product of root c over a, which is p. Basically, this is how any quadratic equation can be written. Now, if we proceed to complete the squares of this polynomial, this quadratic polynomial, we are going to get this. I will begin by isolating this fact. Let's apply completing the square method to solve this quadratic equation, so that I can highlight some important features that we are going to use to solve some quadratic equations. Now, following this property, where you want to complete the square, right? What you do is this: you just take half this coefficient, half of this, half of that gives what? X squared plus b over a x. This is originally what I get at this stage. At this stage, this is what I get. If I want to complete this squares, right, I take half this coefficient, square it and add to both sides. So I'm going to have half of this is what? B over 2a. I square it and I also subtract it, because for my from the lesson I gave under equalities, right, we got something like that: if you have one thing and you're only that one thing, you get nothing, right? So basically this equation is still the same as this one. So I took half the coefficient of x, square it, add and subtract to the same equation. According to equalities, it remains virtually unchanged. Now, this one, the left, this side here is a perfect square. It can be written as x plus, maintain the sign, copy this b onto a, all this square. When you expand this, you are going to get this highlighted here, minus this one, b squared, this that b squared, 4 2a, all that raised to the power 2 will give 2 raised to the power 2 will give 4, a raised to the power 2 is just a squared, plus c over a equals to 0. Now, that is exactly what we get, right? If this was a quadratic function, because it's an equation, because it contains the equality sign, right? If we consider just this part, let's call this function f of x to be given by ax squared plus bx plus c. It means that all these things we have just simplified here is still this equals to 0. Is equal to 0. So this one here represents f of x. So f of x can be written as x plus b on 2a, all that squared, minus b squared on 4a squared plus c over a. This one here can be rewritten as x plus b on 2a, all that squared. Now I can add these two fractions. So I have loss. The lowest common divisor there is 4a squared. Now 4a squared divided by this one is 1 times negative b, so I have negative b squared. Then 4a squared divided by a gives 4a squared divided by a gives 4a times c plus 4ac. So that is what we have, right? This one here, this quantity here, right, when x is equals to negative b over 2a, right, f of x will be equals to what? F of x, because if this one is represented here, you have negative b on 2a plus b on 2a. It's like you owe one thing and you have one thing. Eventually you owe nothing and you have nothing. So you have nothing left with you. F of s will just be equal to this part here. I can rewrite this as 4ac minus b squared. So I have 4ac minus b squared divided by what? 4a squared. Now, following that rule, this one, right, is given by the maximum or the minimum value of the function of the quadratic polynomial. Now, this value here is called what? The axis of symmetry of the parabola. The axis of symmetry, also called the line of symmetry. So, the thing I want to highlight here is that when you are solving quadratic equation, it is important to know this value and also this one. So, I'll call this one x prime to be equal to my axis of symmetry, negative b over 2a. In this lesson, you are supposed to know this value and this one, so that when we get along with the solving, you actually understand everything. Now let's move ahead. This one is called the maximum value or the minimum value of the parabola. I'm going to illustrate all those in a feature. We said that for a parabola, the graph of any quadratic polynomial is a parabola. So if a, the quantity here, is positive, if a is positive, then it's going to take this shape, right? And then if a is negative, is less than 0, anything negative is less than 0, it will take, no, this one, it is when a is less than 0, sorry. So this is a case where it is less than 0. When it is greater than 0, let me change that. When it is greater than 0, it takes a minimum point. This one here is f min. It will be equal to the same value. This one is f max, which will also be equal to this same value here. So when you are solving your quadratic equations, it's important for you to know the sum of roots, the formula for the sum of roots, the product of roots, and the general form in which that quadratic equation can be represented. And also take note of what? The maximum value and the minimum value. Equally, the axis of symmetry. Let's progress to see how this feature can be used to solve any quadratic equation. Consider the quadratic function. Let's say we have this graph. I want to illustrate graphically so that you see clearly. Now, let's say I have this. Let's say I have this this quadratic function. The graph is a parabola. This is a case where a is what? Positive, right? It takes a U shape. Now, this one here, right? This one here is called the minimum value. This one, they are the roots of the equation. The points where the abscissas, where the graph cuts the x-axis, the points where it cuts the x-axis, they are the solutions to our equation. I'll call those solutions x1 and x2. Now, this line where the axis of symmetry occur, like I said, when x is negative b on 2a, we have the maximum or minimum value. So this line where this value occur is called the axis of symmetry. Why? Because it divides the parabola into what? Two equal parts. So this one here is my x prime. X prime is equal to what? Negative b over 2a, as we have seen in as we have seen above here. Now, the next thing I will highlight is to you that in solving quadratic equation, the roots obtained with the quadratic function, the quadratic formula, they are basically the same thing. Observe, this is the axis of symmetry. Now, all roots of quadratic equation, right, they are equidistant from the axis of symmetry, and that's basically what I want to show you guys here so that you can learn. So this distance, right, is also equal to this this distance. I'll call that distance u. So if this distance is u, right, this is also u. Now the first root, x1, is located where? To the left of what? To the left of the axis of symmetry. So I'm going to have the first root x1 to be what? X prime minus u, because when you are moving to the left, you are subtracting the values. So this is actually negative u. Yeah. So I'm minus u. The root that lie to the left of the axis of symmetry is negative. We'll take negative u. The distance is still u in magnitude. Now x2 will be equal to what? This point here is x prime plus this unit. So I have x prime plus u. Now, the next thing we said, while solving this, we know that product of roots p. That means if I'm solving any quadratic equation, if I know x prime and u, I can get the two roots x1 and x2, and I'm done solving the equation. So let's proceed now how to simplify this. Basically, we said that this is what? X prime, right? X prime. X prime is the axis of symmetry. To get u, I'm going to use the fact that the product of roots x1 times x2 is equals to c over a. That's the product of roots. Now, following this rule here, it means that x1 is what? X prime minus u times x prime plus u equals to c over a. Boom. From here now, you will notice that this is a difference of two square identity. The difference of two square identity says if you have a squared minus b squared is the same as a minus b into a plus b. So this is the same thing as, for, if you see this is your a and this is your b. So this is x prime all that squared minus u squared equals to c over a. Now x prime is what? Negative b on 2a. So this implies I have negative b over 2a. All this squared minus u squared equals to c over a. Now, if I square this, I'm going to have negative b squared will give me positive b squared divided by 2 squared will give 4. A squared is just a squared, right? Minus u squared equals to c over a. Now, let's solve for u. Basically, I did a tutorial on how to solve this type of equations, right? On concerning equalities. That if we want to solve for u, our goal is to get the value of u. So if I want to get u, I'll have to do this. I'll have to subtract this from both sides of the equation. And doing that, I can just send this term this way and the sign reverses. So doing that, I'm going to have u squared will be equals to what? B squared minus 4ac squared 4a squared, sorry, minus c over a. You can just send this one this way and you send this one this way. So this one, as it crosses the equality sign, it changes sign, right? So following that, I'm going to have 4a squared. 4a squared divided by 4a squared is what? B squared minus 4a squared divided by a is what? 4a times that 4ac, right? So that is the value of u squared. Now it means that u will be equals to what? Plus or minus the square root of all of this, right? Plus or minus the square root of b squared minus 4ac divided by what? 4a squared. This one here classically gives plus or minus root of b squared minus 4ac divided by what? 4a. I mean 2a, sorry, because the square root of 2 is 4 is 2 and the square root of a squared is just a. Now, that is what we get. The next thing I want to highlight is this. We have two values of u. We have the first value, u equals to the positive root of b squared minus 4ac divided by 2a. And we also have u equals to negative root of b squared minus 4ac divided by 2a. The next thing now is to get x1. My x1 is just x prime. What is x prime? Negative b on 2a. So I have negative b over 2a minus u. If I go for this first value of u where it is positive, I'm going to have minus square root of what? B squared minus 4ac divided by 2a. Basically, this can be written as negative b minus root of b squared minus 4ac. All this divided by 2a. That is x1. Let me just write down x2 down here. So x2 is equals to what? X prime is what? Negative b over 2a plus, I'm still with this first root, the first value where it is positive, square root of b squared minus 4ac divided by 2a. So basically, I'm going to have negative b plus square root of b squared minus 4ac divided by 2a. When you are adding two fractions with the same denominator, you can just maintain, or adding or subtracting, you can maintain the sign between the numerators and just copy the denominator as a single fraction. So that's what I have. If you look at this is the same scenario with the quadratic formula. So basically, the roots are x1, x2 equals to what? This is the case where we have a positive sign, and this is the case where we have a negative sign. Now, this I'm going to have negative b plus or minus square root of b squared minus 4ac divided by 2a. Basically, this is a quadratic formula, right? This is a quadratic formula. So this is a quadratic formula. We have everything intact. Now, that is basically what we get when we solve quadratic equations using symmetry of the roots. So I'm going to draw up a note on how this is being carried out. Do you know why I use just this one, the value of u where it is positive? We know that we were just looking for the magnitude of u. we are looking for the magnitude of u. That's a positive value. We are not interested in the negative value, because x1, according to my definition, is a root where we have normally when you solve this one, even if you don't denote, if you solve this one right and replace here, the roots are going to swap each other, and there are still roots of that quadratic equation. So it really does not matter. But go for the positive value. Once you get your u, you can now get x1 and x2. So that's basically how you solve quadratic equations using symmetry of the roots about the axis of symmetry. So I'm going to drop to you guys now, while you are solving in your exam paper, how can you now present this idea? So in solving, you call the root, right? So let me give you a quick, a short note on basically what it is all about. Now, I'm going to get that if I'm solving any quadratic equation, right? Solving any quadratic equation using the symmetry of the roots, we proceed as follows. The first thing I'm going to do, the first step is to look for what? We let x1 and x2 be the roots of that equation, right? The second step is to define find s and p. Basically, look for the value of p, actually product of roots and the sum of roots. The third one, you look for what? We look for the value of what? X prime in bracket axis of symmetry. So follow the previous discussion, you'll see all those values. S prime, you look for the value. Product of root, we said is c over a. Axis of symmetry is negative b over 2a. Then the next step is to define the last one, to define x1 as x1 equals to what? X prime minus u, and x2 equals to what? So we define x2 as x2 equals to what? S prime plus u. Then we use the last step now is to use the fact that x product of root, right? We use product p equals to c to look for u. Once you get the value of u, you can now replace it here to get x1 and x2. So I'm going to do one example on this so that you see how it is short and simple to use. Let's consider that's basically how you solve quadratic equation using symmetry of the roots. Follow these steps and you get it done. Now, before you go to that example, I want to show you that if you have been asked to factorize any quadratic equation, any quadratic polynomial, right, it can be factorized based on the roots of that equation. We have seen from polynomials that factorizing any algebraic expression helps us in identifying all the roots, all the common factors, which when multiplied gives back the original expression. So if I have a quadratic polynomial, right, let's say f of x equals to ax squared plus bx plus c. Knowing the roots of x1 and x2, right, I can write this one f of x as x minus x1 times x plus x2. So if you are asked to factorize any quadratic polynomial, you can follow these steps to look for what? X1 and x2, and just come and substitute into this formula. That is basically what it is. Now, let's look at how this can be used. Let's go by an example now so that you get acquainted with the methods and also practice alongside with a piece of paper. The first question says we should solve the quadratic equation x squared minus, let's say, plus x minus 2 equals to 0. Now we should solve this quadratic equation. Okay, let's see how we can use these facts using symmetry solve this quadratic equation. Step number 1, we said that we should look for what? We let the roots be x1 and x2, right? You define your whatever you're doing on your paper. So I will let x1 and x2 be the roots. Okay, next step is to use what? We should look for what? The sum of root and product of root. Basically, we are going to use just the product of root because we are not using the sum of root in looking for u. So product of root p, that's what we are going to look at it. You can spell it out during your exam paper. You spell out the value. You define your term where p is product of root. Product of root is c over a. Comparing this quadratic equation with the general form ax squared plus bx plus c, we see that a is equal to what? The coefficient of x squared, which is just 1. B is a coefficient of x, which is just 1. And C is a constant term, which is negative 2, not positive 2, negative 2. So C is negative 2. If I replace it here, negative 2 over 1, which gives negative 2. So I get my product of root to be that. I know that my x1 will be equal to what? X prime minus u. Then I also know my x2 will be what? X prime plus u. Now, we proceed like this. We need to get a value for x prime. X prime is equal to what? Negative b over 2a. What is b? B is 1, right? So negative 1 over what? 2 into 1. A is 1. So I have 2 times 1 is 1. I mean 2. And negative 1 divided by 2 is negative 1 over 2. Like that. So that's my x prime. X prime is that. So it means that my x1 will become x prime, which is negative half minus u. And then my x2 become what? Negative half plus u. We know that product of roots p is equal to negative 2 and is given by what? X1 times x2 equals to negative 2. What is my x1 and x2? x1 is negative half minus u. All this squared, times x2 is negative half plus u, which is negative 2. This is basically the difference of two square identity. This is my a and this is my b. So I have negative half, all this squared. Or you can expand it. Yeah, the same way you were taught in class, you can expand and you should get the same expression like the way I have here. This equals to negative 2. Now, negative 1 squared is just 1. 2 squared is 4 minus u squared equals to negative 2. So from here, my u squared, if I send this way, you make u squared the subject of the formula. You get 1 on 4 minus plus u plus 2. Basically, this one will give you 8 over 8 plus 1 divided by 4, which is 9 over 4. In that respect, means that my u will be the square root of 9 over 4. I'm going just for the positive value of u. The square root of 9 is 3. The square root of 4 is what? 2. Voila. So that's my u. So it means my x1 will just become what? My u, negative half minus my u, 3 over 2, which is just equal to negative 4 on 2. We said whenever we are subtracting or adding two fractions with the same denominator, we just apply the operation just to the numerator and maintain the denominator. So this one is just basically negative 2. Then now, my x2 become what? Negative half plus x2 is negative half plus u, and u is what? 3 over 9. 3 over 2, which gives what? Negative 1 plus 3 over 2, which is what? 2 over 2, and that gives 1. So these are the two roots of this quadratic equation. So my roots, I have x is such that x is equals to negative 2 comma 1. Those are my roots. X is equals to negative 2 and x is equals to positive 1. Now, if you were asked to factorize this quadratic equation, right, you could use the fact that any quadratic equation can be factorized in this format. So I'm going to use that formula here. So if I was factorizing this quadratic equation, for instance, let's say x squared plus x minus 2 equals to 0. Knowing the roots of this quadratic equation, I have x minus x1 into what? X plus x2 equals to 0. It means my x1 is what? My x1 was negative 2. So I have x minus negative 2, like that, into x plus x2 is what? Positive 1 plus 1 equals to 0. So basically, that is what we get. So from here, negative times negative is positive. So I have x plus 2 into x plus 1 gives 0. So this is actually how another person can proceed from here. Once you know the rules x1 and x2, right, you can just come and replace to factorize that quadratic equation. I hope this video helped, and thanks for watching. Please, if you are new to my channel, kindly hit the subscribe button and turn on the notification bell so that whenever I drop new videos, you will not be left out. You'll be the first to be notified. Now, drop your comments in the comment section about how good this video is, because those recommendations will enable me to create more wonderful content for you guys. And thanks for watching. Bye.